So, good morning, everyone, and welcome to this special lecture. We will deal with kinetic theory of gases. We'll try to start this and finish this in this particular chapter, in this particular class. What do you mean by kinetic theory of gases? Anyone, any idea? What do you mean by kinetic theory? Anyone knows anything about it?
Kinetic related to gases, moving gas particles.
Theory means it is just a theory, it cannot be verified. And whenever you call something theory, it cannot be verified, but it can explain most of the things that we observe. It can be explained by this. It cannot be experimentally verified, so it is a theory. Big Bang theory, theory of evolution, all these are theories. Can't be experimentally verified, but we can explain it with some conceptual things and we call it theory. Okay, got this? That is what a theory is. Difference between theory and law. Theory is not experimentally verified. So that is theory. Now, this kinetic theory, if we see, um, there are two types of properties of a. There are two types of things that we can call in a gas. One are known as microscopic, and one is known as macroscopic property and microscopic property. Macroscopic, macro, and micro. Now, micro means small, macro means big. What are these microscopic thing that is happening inside a gas? We have molecules of the gas and which are moving in all sorts of random directions, and they are doing certain things. Those are microscopic properties which we cannot see with our naked eyes, which are very difficult. Then there are some macroscopic properties which can be easily seen and experienced. The macroscopic properties are the combined effect of these microscopic things that are happening. Macroscopic properties are properties like what? Pressure. We can easily measure temperature. We can easily measure pressure, temperature, volume. These are like cumulative, bigger properties of the gas that can be easily understood or measured. But these macroscopic properties are coming from this microscopic behavior. Whatever is happening at this microscopic level, small level, it is leading us to this macroscopic properties or bigger properties. Do we understand this?
Yes, sir.
Have you noted this down? Now, when we talk about these microscopic properties, these are the properties or these are things that are happening at a very minute level with molecules and with atoms of the gas. Now, if we compare these gases with the other states of matter, solids and liquids, we all know. I mean, it's just a comparison between. Oops, what has happened here? If we compare these gases with solids and liquids, the distance between the molecules of a solid are very small compared to liquids, and gases have the most distance between the molecules. Therefore, their intermolecular forces, if I talk, solid has the most intermolecular forces, then liquids, then gases. Now, whenever we're dealing with gases, we'll come across this term which is known as real gas, and we'll come across this term which is known as the ideal gas. Now, in most of the cases in physics, we'll be dealing with ideal gases. Now, when we say the gases are ideal, these ideal gases, as you can see, have a very peculiar property. And what is the property of these ideal gases? We assume that the intermolecular forces in this ideal gas are zero. Do we understand this? That means when we are considering gas as an ideal gas, there is no force that exists between two molecules of the gas, and that is a very important assumption. Because of that assumption, this potential energy, now the potential energy is minimum in solids, maximum in gas because of intermolecular distance being too large. But since we consider the force between the gas molecules as zero, we also consider the potential energy of this gas being zero. Do we understand this? That's a very important consideration that we are doing. Potential energy of this gas molecules is taken as zero. That means these gas molecules don't have any potential energy. Then what type of energy they are going to have? They only have
Kinetic energy.
they only have kinetic energy. They only have kinetic energy, and that is what we must understand, that potential energy is zero for an ideal gas. They only have kinetic energy. Now, at a given temperature for any solid, liquid, or gas, the internal kinetic energy is same for all. The internal potential energy, remember, for a gas, ideal gas, this internal potential energy is maximum and it is taken as zero. Okay. Now, when we add this internal kinetic energy and internal potential energy, we will come to this. We will get the internal energy of the gas. This internal energy of the gas is normally written as U, and we will come to this U very soon. We will understand this U. Okay. This is what we call an ideal gas. Now, when we start this concept, we will start with the concept of an ideal gas, and then we will start to build up this concept. So, ideal gas is a gas where intermolecular forces is zero. Do we understand this? The concept of ideal gas?
Yes, sir.
Intermolecular forces is zero, and that is the gas that we call as ideal gas. Do it fast. Just note down things in very, very short language, not in complete words, complete sentences. Note down in short. Ideal gas. An ideal gas is a gas that follows all your gas laws. PV is equal to nRT, Charles law, Boyle's law, this law, that law. That is an ideal gas. When we have an ideal gas, the volume of the gas molecules is very negligible compared to the volume of the container, because these molecules are very, very far from each other. So the actual space occupied by the volume will be very small. We will deal with all these assumptions in the ideal gas theory, in the KTG theory. This is just for your ideal gas, so that we get the concept of this ideal gas. No intermolecular forces exist. That means the potential energy of this gas or gas molecules is zero. Remember, we are talking about the assumptions of an ideal gas. Obviously, no gas in this universe is ideal, but these are just our assumptions. If a gas is ideal, then these things should be valid. Please note them down very, very carefully. This will help us in understanding. and building the concept of this kinetic theory of gases, because when we are dealing with kinetic theory of gases, we are taking gases as ideal gases. Potential energy of this gas is zero. So the internal energy only consists of translational word is wrong. It only consists of the kinetic energy of the gas, which is directly proportional to the absolute temperature. Remember, for a gas, since the potential energy, for an ideal gas, since the potential energy is zero, the internal energy U only consists of the translational kinetic energy. Do we understand this? Kinetic energy of these gas molecules or any particle, it only depends on the temperature. If you increase the temperature, the kinetic energy of the gas molecules will increase. I hope you understand this. You understand this, yes or no?
Yes, sir.
Keep on noting this point about ideal gas, because sometimes they also ask you the properties of an ideal gas as an objective question. What is the property of an ideal gas? And this graph that I am showing it to you has come many times in the exam. And this is not there in your book, so just see it. Ideal gas, specific heat. Do we remember this term, specific heat, from the last class?
Sir.
Specific heat, the amount of heat required to raise the temperature of 1 gram or 1 mole by 1 degree Celsius. The specific heat of an ideal gas is always a constant, and it does not change with temperature. C, the ideal gas, for an ideal gas is always constant. So if I draw the graph would be like this, straight line, ideal gas. But for real gases, this graph is not same. The molar specific heat or specific heat is not constant, it keeps on changing. So this is on the right hand side, we have a gas which is real. Okay, now they might give you these 4 graphs and they might ask you which is the graph for which gas. Now remember, all real gases at high temperature and low pressure, will behave as an ideal gas. This is a very important consideration that you should remember. This might be a difference between +4 and -5. They might give you the graph of CV and T for an ideal gas, but then for a real gas, then they will say that this is the graph of C versus T for a real gas at high temperature and low pressure, which is the graph. So they will give you, let us say, these 2 graphs, and as soon as you see graph number B, you might mark graph number B, but graph number B will not be correct, because in that case the gas will be behaving as an ideal gas and this graph would be correct. Do we understand what I'm saying? So
Sir.
at high temperature and low pressure, ideal gas, real gas behaves as an ideal gas. Only when the temperature is low or the pressure is high, they behave differently. They deviate from the ideal gas behavior. We understand this?
Yes, sir.
Okay. Then there is a term known as a volume expansion coefficient and pressure expansion coefficient. Basically, this term means we have seen the expansion of solids and liquids, and I told you that gases, we will see this expansion coefficient in this chapter. This is the volume expansion coefficient and pressure expansion coefficient for an ideal gas, and it is constant for an ideal gas, and it is 1 by 273. This 273 comes from that ideal, from that Kelvin scale wala temperature. So 1 by 273, alpha and beta, the coefficients are common. whether you call it volume coefficient or you call it the pressure coefficient, pressure expansion coefficient. Remember, for any gas, whatever term we have, we will have it for constant pressure. We will also have it for constant volume. Do we understand this? Okay. Now, everyone has written this?
Sure.
Then we move on to the next heading, which is your ideal gas equation. Everyone knows ideal gas equation? Can you tell me what is the ideal gas equation?
P equals to nRT.
What does P stand for? What does V stand for?
P stands for pressure, V stands for volume, N stands for moles, R is a constant, and T is the temperature.
Okay. So remember, we will see the different variations of this equation. PV is equal to capital N RT. Now, whenever I say capital N in this chapter and from there on, capital N stands for the number of moles. Capital N always stands for the number of moles. Remember this. Whenever I use capital N, it stands for the number of moles. Now, whenever number of moles will come, and we will see it, whenever number of moles come, capital R will come with number of moles. Capital R, the universal gas constant, it always comes with the number of moles. Do we understand this? Yes or no? Huh?
Yes,
You
sir.
understand this? Now, let us look at the second form of this equation. PV is equal to nRT. N is the number of moles. How can you write the number of moles? Yes, do it fast so that we can write all the forms of ideal gas equation. And this is a revision of your physics as well as your chemistry. Yes, what is the other way in which you can write this? PV is equal to M by M naught RT. What does M stand for, or what does M naught stand for?
M stands for given mass, M naught stands for molecular mass.
M stands for the given mass and M naught stands for the molecular mass. Everything has to be in kgs. Even though it is not in kgs, both are in grams, they will cancel each other out. So you don't have to actually convert them from gram to kg. Even if they are in grams, both are in grams, they will cancel each other out. This is the second form of equation, the ideal gas equation. Can we now write the third form? What is the third form? And this is the form that we are going to use at many stages. All these form number B may not be important in physics, because we might not be using form number B, but form number C is important in physics. Yes, form number C comes like this: P is equal to rho RT by M naught. A very important formula which we are going to use in a lot of places. What does rho stand for?
Density.
Rho stands for the density of the gas. Rho stands for the density of the gas. And if everything is good, density of the gas will remain constant everywhere. But obviously, we will see questions where density of the gas varies, and then you will have to find something. Do we understand this? This is the third form of the equation. Everyone is getting me? Yes or no?
Yes, sir.
Okay. Now, there's a fourth form of the equation. Now, this fourth form of the equation can be derived from the first form. I can write this as PV is equal to small n by NA RT. Yes or no? What is this small n? Now, whenever this small n comes, this small n always stands for
Particles.
Number of particles, it can be number of molecules, it can be number of atoms. Maybe molecules, let me call them molecules. Number of molecules, or number of particles, or number of atoms. And what is Na?
Avogadro's number.
Avogadro's number. Now, as soon as I have R, which is a constant, and Na, which is a constant, R by Na is known as R by Na is known as the Boltzmann constant. So now I have this form of the equation, small n k t, where k is the Boltzmann constant. Now what you have to remember is whenever you have small n, number of moles or number of particles or number of atoms of the gas, with small n, always k will come. With small a, always k will come. And with number of moles, always R will come. So whenever we talk about per mole of something, per mole of something, R will come there. When we talk about in terms of number of moles of the gas, when we talk about in terms of number of particles of the gas, we will always have this K coming in. Do we understand this? Yes or no?
Yes, sir.
Now, we can do a couple of problems on this so that we are done with this ideal gas. Normally, I take a lot of problems on this ideal gas, but we have to finish everything in a jiffy. So I will take very few selective problems, 2 or 3, so that I understand that you understand this concept of ideal gas and you know how to use the equations. This one, this type of questions are coming these days because you may call them question of thermodynamics, you may call them question of error analysis, percentage error analysis, whatever. Both the questions are combined here. By increasing the temperature of a gas by 5 degrees Celsius, its pressure changes by 0.5 for initial from its initial value at constant volume. What is the initial temperature of the gas? Give you 1 minute to know this sum, to solve this sum. Simple questions, don't worry. Questions are pretty damn simple. If you understand them, the questions are pretty damn simple. Yes, bacha. Anyone? Oops, I thought it's a simple question. Shall I do it? I'll give you 1 more minute. Simple question. You have done this ideal gas equation before, yes or no? Have you done this ideal gas equation before? No answers.
Yes, sir.
You should be able to do this. You know the ideal gas equation.
$281K, sir.
281K. No, I don't think so. It's not 281K. That means I have to do it. Yes or no? I need to do it. Yes?
54.
How have you done this? I am not worried about the answer. How have you done this? I know that I did not teach you thermodynamics, so I don't. Yes, how did you do it better? More concerned with your procedure rather than anything else. Yes. Are your voice is not coming better.
PV equals to NRT, sir.
PV equal to nRT. Yes, sir.
Given 5% pressure is increasing by 5%, 0.5%.
Right. 0.5 or 5?
0.5.
Yes, yes. So
P into 5 by 500 into V equals to NRT into given temperature. We should convert the 5 Celsius into Kelvin, sir. 478 Kelvins. And we have one more equation, PV equals to NRT. We should divide both equations. Pressure, volume, both will cancel. We will get T from that.
okay. Okay. So what you have seen is that this is as constant volume. Let me show you my way of doing it. PV is equal to capital N RT. At constant volume, volume is constant. This goes away, this goes away, this goes away. So here pressure increases. So I can write at constant volume, temperature is directly proportional to pressure. Yes or no?
Yes, sir.
So from here I can write them percentage wise. Change in temperature divided by the original temperature into 100 will be equal to change in pressure upon original pressure into 100. Yes or no?
Yes, sir.
That's it. That solves your question. Change in temperature is given as 5 degree. This entire thing, change in pressure divided by pressure into 100 is given as 0.5. You just put the values there and you will get the value of temperature. Remember, as I told you, I'm doing very specific questions. So remember all these questions because these questions can come in your physics as well as your chemistry. This is a topic which comes both in physics and chemistry. So I'll be covering both your physics and chemistry from here. That's why it's important that we do thermodynamics. What is the value of temperature coming, bacha? Yes, bacha? Anyways, it will come as 1000 kelvins. That is the answer that we are looking at. 1000. Okay. We understand this? Yes or no?
Yes, sir.
Okay. Let us move quickly on to the next question again. As I said, I'm doing a very peculiar, very pinpointed questions. Please do them carefully and give me the answers fatafat so that we can move ahead in life. This is the next question. Again, this question is common to both physics and chemistry. If the chemistry paper becomes more very tough, this question will come. It can come in physics, in JEE Advanced as well, apart from JEE Main. Question number 2. A closed container of volume something something contains a mixture of neon and argon at a temperature of 27 degrees Celsius and a pressure of 1 into 10 raised to the power 5. The total mass of the mixture is 28 grams. If the gram molecular weights of neon and argon are 20 and 40, find the masses of the individual gases. Remember, neon and argon are they are not interact. They don't react with each other. Non-reactive gases. Have you done question like this before? Okay. Take your time. Do it. We have time, enough time to complete this. Don't worry. Only 3 or 4 questions you need to do, and we are done with ideal gas equation. Don't worry. And I'll cover all the questions. If I cover a topic, I'll cover all the topics. Whatever time I have. Do it. Well, you're not able to do this, then I must step in. How will you do it? These are non-reactive gases. Dalton's law of partial pressure. You can either find a partial pressure, pressure of one gas and pressure of second gas and add them, or you can do the next best thing, just find the total number of moles. How will I find the total number of moles? Total number of moles, N, will be number of moles of N1 plus number of moles of the second gas. If I say that the mass of neon is M, the mass of argon will become 28 minus M. Yes or no? So total number of moles will become M divided by 20 plus 28 minus M divided by 40. Do we understand this? So you can find out how much this will come. I think this will come as we take 4 common 28 plus m by 4. Yes or no? 28 plus m divided by 40. You know the number of moles. Now you can put PV is equal to nRT and you will end up with your pressure. Either you can do it this way. First find the total number of moles and from there you can find out the pressure, or you can do it like this. Total pressure will be partial pressure due to neon plus partial pressure due to argon. I think this is simpler and you will get the answer quickly from here. Do you understand this? Can you calculate and tell me the value of m now? I'm giving you 2 minutes to do it. You've taken so much of time to calculate this, or it is not worth it. If you're taking so much time, that means it's a useless question. You will not be able to solve it in the examination hall. Why are you taking so much time to calculate this? Is everyone awake in the class? Yes or no?
Yes, sir.
Why are you taking so much time to calculate this? Anyways, the mass m is coming as the answer I have is 4 grams. So mass of neon is 4 grams and the mass of argon is 24 grams. So just write the answer. We don't have that much time that I can give you for calculating. Your calculation skills, I am really very apprehensive about it. If these are your calculation skills, then you must improve on them. Please improve on your calculation skills. Calculation skills are not up to mark. Please calculate things quickly, beta. Otherwise, it's not good. But the other good thing is you might not get such questions which require so much of calculations. But anyways, your calculation skills should be better than this. Should be able to find out the answer quickly. Okay, this is the next one. Do it fast. Question number 3. During an experiment, ideal gas, the gas is ideal, is found to obey an additional law, and we will come across this question a lot of times, but then we will find out probably the work done or change in internal energy. Here we are finding out something else because these questions are coming these days in your JEE. During an experiment, an ideal gas is found to obey an additional law, apart from whatever law it follows. Vp square is constant. The gas is initially at temperature T and volume V. What will be the temperature of the gas if it expands to a volume 2V? JEE NEET, both students, this question can come in both your JEE as well as NEET. Anyone got the answer? Yes, beta?
Root 2t, sir.
Root 2t are good. That is correct. So how are you supposed to find this? We are given that Vp square is constant. And what is the way of doing it? We have to find the temperature of the gas when the volume expands to 2V. So basically you have to find the relation between T and V. Now, if you have to find the relation between T and V, what you do is you eliminate P from here. How do I eliminate P from here? You put the value of P from your ideal gas equation. Remember, your ideal gas equation was PV is equal to nRT. Now, remember this, N and R are only constant, so just forget about them. So you can put P in terms of T and V. You can put P as T by V, and you can put this value. This is how we do every question like this. We put this value here, not in place of P, but in place, not in place of V, but in place of P. So you get the relation between T and V. What is the relation that you're going to get between T and V? V into T square by V square is constant. This is the equation that you're going to get. So basically we'll get the equation T square by V is a constant. T square by V is a constant. Once you get this equation, the rest of the thing is very simple. T1 square by V1 will be equal to T2 square by V2, or I can write T2 as T1 into root over V2 by V1, and that gives you the required answer. Do we understand this?
Yes, sir.
These type of questions are going to come in your exam, whether it is JEE Main, whether it is JEE Advanced, whether it is NEET. So please, please, please be attentive and solve these questions. Got this, everyone?
Sir.
This one, fatafat. Questions from previous year, JEE NEET. When volume of a system is increased 2 times and pressure is decreased half of its initial temperature, the pressure becomes how much?
Option C, sir.
Option C, sir. That is correct, sir. Option C, sir. So we understand how to do this. P1 V1 by T1 is equal to P2 V2 by T2. We understand this, everyone?
Yes, sir.
P1 V1 by T1 is equal to P2 V2 by T2. Just put the value of P1, V1 and T1. Just put the value of V2 and T2. You will get the value of P2. Everyone understand this? Can I have raise hands from everyone that you understand this? Okay. Next. Okay. This is a slightly different question. Normally, we don't get these questions because the mass of the gas or the number of moles of the gas remain constant. But that is the difference in this question, and you must understand the difference and solve the question accordingly. A flask is filled with 13 grams of an ideal gas at 27 degrees Celsius. The temperature is raised to 52 degrees Celsius. The mass of the gas that has to be released to maintain the temperature of the flask at 52 degrees Celsius, the pressure remaining same is. What is constant in this? I mean, if the question was not of mass of the gas, what was constant in this particular question? Whenever some process happens in a cylinder which does not have a moving piston, a fixed cylinder with fixed walls, or a flask or a vessel, it is always question of constant volume. Do you understand this? Volume remaining constant. This process is happening in a flask, therefore the volume is constant. Do we understand this?
Yes, sir.
Volume is constant. But here they have given an additional condition. What is that additional condition? Pressure should also remain same. So pressure is constant. Volume is constant, pressure is constant. But what we are changing is the temperature of the gas. Temperature is changed. So you'll have to change something to maintain the state of the gas. What will you change? That is the question. Obviously, you are going to change the mass of the gas. So here N is not constant. The number of moles or the mass of the gas is not constant. I'll give you 2 minutes to solve this. Shall I do it?
Option B, sir.
Option B, sir. Option B is 2 grams, sir.
D, sir.
D, sir, 1 gram. That is correct, sir. Option D, sir, 1 gram, sir. That is correct, sir. Well done, sir. How did you do it, sir? Oops. How did you do it, sir? Tell me. Oops. Wrong color. Yes.
Temperature is inversely proportional to mass.
Temperature is inversely proportional to mass. I can write the equation PV is equal to M by M naught into R into T. Now here, as you can see, P is constant, V is constant, number of moles is constant, R is constant. So I can, in this case, say mass into temperature M1 into T1 will be equal to M2 into T2. Yes or no?
Yes, sir.
So from there, you can find out the value of M2, total mass, M1 into T1 by T2. How much is T1 and how much is T2?
T1 is
T1.
300.
Remember, not 27 degrees Celsius. Always keep the temperature in Kelvin scale. T1 is 27. So put the values. M1 is how much? 13. Multiplied by T1 is 300. Divided by how much is T2, bacha?
325.
325. So if you divide this, what will you get? I think you will get 12 grams. Yes or no?
Yes, sir.
Final mass of the gas is 12 grams. Initial mass of the gas is 13 grams. How much mass has to be released? And the answer is 1 grams. Well done. Good. Remember, these type of questions can come. If you are prepared for them from the very beginning, you should be able to do. Are we ready for the next one? Do we understand how it is done?
Sir.
Okay. This is the next one. This question has come in JEE, it has come in NEET, it has come in engineering exams, it has come in medical exams. It's a very pet question. Air is filled at 60 degrees Celsius in a vessel of open mouth. Now look at the language of the question and try to understand what is there and what is not there. Air is filled at 60 degrees Celsius in a vessel of open mouth. The vessel is heated to a temperature T so that 1/4 of air escapes. Assuming that the volume of the vessel is constant, thermal expansion is not there, find the value of T. Yes, my dear friends. Huh? Any answer? Remember, these questions are common for JEE NEET. They're also common in physics and chemistry of JEE and NEET. So we are doing 4 topics at the same time. Chemistry for NEET, topic number 1. Chemistry for JEE, topic number 2. Chemistry for physics for NEET or JEE, topic number 3. Physics for JEE, topic number 4. We are doing 4 topics at the same time. Please pay attention. And all these questions are common. I'm only taking those questions that are common for both. All the 4 things. Yes, anyone with any answer?
Sir, option A.
Option A, 80 degrees Celsius. No, bacha, that is not correct. You have to read the question carefully. 1/4 of the air escapes. Shall I do it?
Option B, sir.
Option B is also wrong. It is not 440 degrees Celsius. So, as we had seen, PV is equal to M by M naught KT or M by M naught RT. What all things are constant here? Volume is definitely constant because volume remaining constant is given. Anything else is constant? This vessel has an open mouth. It's open to atmosphere. Therefore, pressure is constant. Remember this open vessel. Whenever a question comes of open vessel is open to atmosphere. Therefore, the pressure is constant. Do we understand this?
Yes, sir.
Then this is constant, M0 is constant, R is constant. This question becomes the same as question number 1. M1 into T1 becomes M2 into T2. Now, if I say M1 is capital M, what is T1? T1 is 63 degrees Celsius, so it is 333 Kelvin. Will be equal to M2. 1/4 of the air has gone out. So how much has remained? 3/4 of the air. Do we understand this?
Yes, sir.
Multiplied by T2. M and M gone. T2 is 4 by 3 into 333, 444. So the correct answer is option B, 444. Yes or no?
Yes, sir.
Everyone understand this? Yes or no? Please raise your hands. The answer is
No,
444.
sir.
You understand
Yes,
this? Yes
sir.
or no?
Yes, sir.
No, sir.
No, sir. It's 444 now. Option is given 444. What is the problem?
It's in Kelvin.
It's in Kelvin. Choti si cheez na. And you mark the question na, and you go move forward na. Instead of +4, you get -5 na. Answer is 171 na. Anna. Got it?
Yes, sir.
Since Kelvin, not in degrees Celsius. Remember this. We always get the answer in Kelvins and not degrees Celsius. Next one, fatafat. This is important because this comes in your thermometry as well. The expansion of an ideal gas of mass m and pressure P is given by the straight line D. Then the expansion of the same ideal gas is given by the straight line which yeah, since we have this graph, this would be a time to ask you from where does this graph start for all the gases? Thermometry.
Absolute zero, sir.
Okay, chalo, good. That is why I wanted to point out. Now tell me the answer. The expansion of an ideal gas of mass m at a constant pressure P is given by the straight line D. So this is the straight line D. When it is at a constant pressure P, then the expansion of the same ideal gas at mass 2m and pressure P by 2 is given by which straight line? This question looks tida, but it is a see the question. These are the type of questions that are coming. These that test you. They might not give you question based on calculation, but they might give you question based on theory. And how do you apply that theory? First, I'm waiting for the answers. I'm still not getting any answers. Huh? No one knows it. Give you 1 minute.
Sir, option D, sir.
Option D, A. Well done. That is correct, sir. How did you get it, sir? Same thing. PV is equal to M by M naught RT.
P1 by M1 equals to P2 by M2.
No. Nothing is constant here. Look at what is constant. Sometimes we might get the answer by using something which is not correct. Here only these two things are constant, R and M naught. Now remember, this is a graph drawn between PV and T. V and T. So I have to write V in terms of T, my dear friends. How will I write V in terms of T? I can write V as M by P multiplied by T. Do we understand this? Huh?
Yes, sir.
This M by P, bacha, is the slope of this graph. We also understand this. Y is equal to mx plus c. This M by P is the slope of this graph, of these straight lines. Do we understand?
Yes, sir.
Now in case number 1, what is the slope of this graph? It is at M and pressure P. So slope, let me call this slope. Slope will be M by P, and this slope is equal to this line. Now let us find out the slope in the second case. What is the slope in the second case, my dear friends? 2m divided by p is p by 2. So it becomes 4 times the slope of this graph. Now which graph has 4 times the slope of this graph? This graph has a slope of 2. Everything else is same. Which graph has a slope 4 times of this graph? And the correct answer is
Option C. Option D.
option D. And that is how you calculate this. I hope we are able to understand this. Yes or no? Huh? We understand this?
Yes, sir.
Next one, do it fast. Two identical gas balls are interconnected by a thin glass tube. A gas is filled. This is probably not meant for NEET because it will require some calculations. So it probably will not come into NEET. But they might give you the concept, what will remain same or not. So a part of this question can come for NEET, not the entire question maybe. Two identical gas bulbs are interconnected by a thin glass tube. A gas is filled in these tubes with NTP. If one bulb is placed in ice, another bulb is placed in hot bath, then the pressure of the gas becomes 1.5 times what will be the temperature of the hot bath. Pressure has become 1.5 times what will be the temperature of the hot bath. Now, whenever you encounter such question, do you want me to solve it or will you try it?
Will try, sir.
Okay. Whenever there is a question where gases are mixing or from here to here gases are going, remember the total number of moles should remain constant because no gas is coming in, no gas is going out. Remember that. I'll give you 2 minutes. It might require calculation. I will not be doing the calculation part. I'll just tell you how it is done and you have to do the calculation part. Shall I do it?
Wait, sir. Option D, sir.
Okay, we have got an answer. Well done. I was not expecting any answers. Good. You can do this. Option?
D, sir. 546 degrees.
Very good. Now we are picking some speed. Well done. That is correct. Option D, 546. How do you get this? Now you must understand that initially both the temperatures were 0 degrees Celsius. Do we understand this? This is
Yes,
also
sir.
0 degrees Celsius. This is also 0 degrees Celsius. Finally, this temperature still remains 0 degrees Celsius, but this becomes T. Do we understand this? Now, what we have to understand is the gas which is remaining, the number of moles or the mass of the gas remains constant. So N1 plus N2 will be equal to N1 dash plus N2 dash. Do we understand this? Remember, it's a thin tube. So whatever is there inside this tube, we are just neglecting it. Now, what is N1 here? Initial pressure P, volume V, divided by R into 0 degrees Celsius, we write it 273 Kelvin. Plus what is the number of moles on the other side? PV divided by R into 273. What is the final number of moles on the left hand side? P becomes 1.5 P. Volume remains same divided by 273 into R. How much is the number of moles on the right hand side? 1.5 PV divided by R into capital T, where T is the temperature on the Kelvin scale. We can just take out all the things which are common, dung dung, dung dung, dung dung, dung dung, dung dung, dung dung, and just calculate the value of T, which is quite simple. I think you are getting it as 819 Kelvin, right?
Yes,
That
sir.
is 546 degrees Celsius. Do we understand this?
Yes, sir.
These type of questions of mixing of gas do come very, very frequently. So please remember this. I'll give you one more on this, because I feel that these type of questions are very likely to come. So this is the next one. Question number 8 or 9 or 10, whatever. The more the number of questions you do, it is going to come both in your physics as well as your chemistry. Two containers of equal volume contain the same gas at P1 and P2 and absolute temperature T1 and T2. On joining this vessel, joining wala question. The gas reaches a common pressure P and a common temperature T. What is the ratio of P by T? Give me the answer, fatafat. It is as simple as it gets. Huh? Fast. Do not have time. We do not have time. I would request that if you're in the class, please try the questions. Please don't sit ideal. If you want to sit ideal, you can go and rest in your hostel. At least have a break. If you're in the class, please try and do questions. Otherwise, a useless exercise. Just bacha. Anyone with any answers? Anything that looks like an answer? Okay, I shall solve it. Since I am not getting any answers from anyone. Shall I do it?
Sir,
Yes, bacha.
option C.
Option C. Option C. How did you get option C? T1 plus T2 whole square. Interesting. I don't think that is
Sir,
correct.
option
Yes,
D.
Option D, sir.
option D. Yes, option D is correct. Again, we apply the same concept. Number of moles in the first vessel N1 plus N2. That will be equal to number of moles when they are joined together. What is the number of moles in the first case? Pressure is P1. Volume is V divided by R into T1 plus P2 into V into R into T2. That should be equal to the final pressure is P. Remember, it's a very important concept. Final volume has become 2V divided by R into T. You can cancel out the common things and you can end up with the answer straight away. Do we understand this, or this has gone about as saying bye bye? I'm going, don't worry about me.
Yes,
I'm going. Okay, do we understand this? Then fatafat we will quickly go through these these laws, and I hope all of you are aware with these laws. We will do them quickly so that we are all dressed up to do KTG. And the first law is known as what? Already done the whatever dies. The ideal gas equation. We'll just go through these laws fatafat because I'm more worried about the curves. They give you curves on this, and that is how the first law is known as what? Huh?
Boyle's law.
Okay, I can start with the Charles law as well. Okay, I will start with the Boyle's law then. The first law, if you said that is Boyle's law, I was writing Charles law. Oops, what has happened here? Okay, so I'll start with the first law. I written Charles' law. I'll write Boyle's law. Boyle's law. What is this Boyle's law? Tell me, fatafat. Right? Why I'm writing it like this?
PV is equal constant, sir.
Why I'm writing like this? Just a minute. Just let me write. Boyle's law is the first law for a given mass of gas, ideal gas. Remember, at a
Sir, school is pass, sir.
at a constant temperature.
Sir,
At a constant temperature, the volume of the gas is inversely proportional to its pressure. That is what we call as your Boyle's law. So this is how it looks like. The graph is more important rather than anything else. Volume is inversely proportional to pressure. These are the graphs that I wanted to show you. Important point is the graph. Graph between P and V is an hyperbola. PV and V is a straight line. PV and P is also a straight line. I've seen these graphs in NEET as well as in JEE, and that is why I wanted to do this. Simple questions. Based on this, a graph for NEET students, it would be simply graphs. And you might get a simple question as well, and that I will give you. Write this, draw this graph, and we can move ahead in life. Shall we move ahead in life? Yes or no? No, yes. Huh?
yes, sir.
This is a question, a very, very important question. I have seen it come many times in different ways. Sometimes it looks like a question of hydrostatics. Sometimes it looks like a question of thermodynamics. It's a mixed question from hydrostatics and thermodynamics, something of hydrostatics and something of thermodynamics. Important for JEE Mains and JEE Advanced. For JEE NEET, they might not give you the values. They will give you this question in terms of algebraic values. Height is h. What is the height of what is the depth of the lake is d. What is the value of d? Because it might require some thoda sa calculation. An air bubble doubles in radius on rising from the bottom of the lake to its surface. If the atmospheric pressure is equal to 10 meters of water, what is the depth of the lake, my dear friends? Depth of the lake. Let's see who gives me the what? Correct answer. Do it fast. If you do it fast, we will be able to cover more questions. If you don't do it fast, I will have to let go some questions because I have to finish KTG today, no matter what happens in this universe. I'll have to finish it. So if you don't do question fast enough, I will have to see. I'll have to extend it to the next class, which I don't want actually. I want you to complete it here so that in the next class I can start with KTG, can start with thermodynamic processes. And the next class I can do heat transfer and we are done with heat once and for all. Yes, my dear friends, anyone with any answer? Anything that looks like an answer? No one? Shall I help you out? Now, obviously, there is nothing given about the temperature. That means the temperature has to be taken as constant. So what do you need to apply here is your Boyle's law. We understand Boyle's law? P1 V1 is equal to P2 V2. Now, P1 V1 is equal to P2 V2. That is what we need to apply. P1 is the pressure initially, V1 is the volume initially, P2 is the pressure finally, and V2 is the volume finally. Now you have to understand what is the relation between the pressure on the top of the lake and the bottom of the lake. This is the top of the lake and this is the bottom of the lake. I hope you understand this small thing. If you don't, that is why I am showing the solution. The pressure here at the top of the lake is normally known as P naught. P naught, not meaning atmospheric pressure. The pressure here is P naught. Then there is water in the lake. What will be the pressure at the bottom? Anyone? P naught is the pressure on the top. We are going a depth H inside water.
Not plus rho g h, sir.
That's it. Well done. So that is all you need to know, beta. This is P naught plus rho g h. This P naught plus rho g h is the pressure at the bottom. So that is the pressure P1. This P naught is the pressure on the top. It is P2. And we are done. So I put the values. Now P naught is given as equal to 10 meters of water. So I can just put it like this. 10 plus H into rho into G. Do we understand this? Yes or no? Yes or no?
Yes, sir.
If I call this volume as V, which is on the bottom of the lake, when it comes on the top of the lake, the radius becomes 2 times. If the radius becomes 2 times, what will happen to the volume? How much time will it make?
4 times. 8 times.
8 times. R cube, 8 times. Pressure is equal to 10 because it is atmospheric into rho into G into 8 times V, my dear friends. As soon as you write this equation, we are done. You can calculate the value of H. Remember, it's a very important question. I've seen it come many times in many exams. What is the answer that you are getting?
80, sir.
8, sir.
Can't calculate this, hey Bhagwan. May God help them. From now onwards, I'll pray every
-70, sir.
I will pray every morning, every night, every day that may God help you. If you can't calculate this, I don't know what is going to happen in this universe. 70 meters is the answer that you will get. May God help you. Because only God can. You need Lord Krishna or Lord Vishnu to incarnate, to come and save you. No one else can. You can't calculate this. Anyways, that takes us to the next law. I can't teach you to calculate this because I have taught my son to do this and he can do this. If you can't do this, well, it's a gone case. So let us move on to some things that you might know. Calculation is one thing that you don't know, but I hope that you will get calculate. You will get questions which will not require calculation, because even if it requires 80 minus 10 and you will say minus 70 or plus 20 or 80, Next law is known as the Charles law. According to it, for a given mass of an ideal gas, volume of the gas is directly proportional to the temperature, P being constant. More concerned about the graphs, these are the three graphs that you must remember about Charles law. I hope everyone knows this. Yes or no? No or yes? Huh? You know this?
Yes, sir.
Good. We don't know calculation, but we know this. We don't know calculation, but we know this. We can't calculate, but we know this. We don't know how to multiply and divide, but we can do this. Good? Not bad? कोई बात नहीं. Sometimes all of us make mistakes. I have also made very stupid mistakes in my life. But should always make fun of your stupid mistakes and feel ashamed about it, because then you will not repeat them. So if I do a mistake, I really feel very sad, very ashamed, so that I don't repeat it in the next time. That is why I'm telling you this. I hope you understand. Have you noted this down, bacha?
Yes, sir.
Okay, sir. Then, sir, one small question, sir. Do it fast, sir, so that I can move on ahead in life, sir. Do it fast. This question for JEE as well as for NEET. Common question for both the students. Here comes. Very simple. 1500 ml of gas at room temperature, 23 degrees Celsius, is inhaled by a person whose body temperature is 37 degrees Celsius. If the pressure and the mass stay constant, what will the volume of the gas in the lungs of the person? Obviously, this question is made specifically for NEET. How much you inhale, outside temperature, inside temperature, inhaling your. I hope we can manage it. Again, this might require some calculation, but you may not tell me the calculation part. You may just tell me the fraction part, and that would be good enough. I think we have taken so long to do this. Not able to do this still.
Sir, 1575 milliliters.
Okay, let us see. So PV is equal to nRT is what we understand. So from there I can write V1 by T1 is equal to V2 by T2. Oops, V2 by T2. What is the value of V1? The value of V1 is 1500. T1 is 23. V2 we have to calculate. And T2 is given as 37. You just need to put the values, get the answer and stay happy. Yes or no?
Yes, sir.
1417 ml, sir.
Someone is getting 1417. Someone is getting 1517. What is the answer? Will the volume
1550,
increase or will
sir.
the volume decrease? Will the volume increase or will the volume decrease?
Increase, sir.
Increase, sir. So the girl is correct, sir. You are wrong, sir. Shall I do it or we understand this? Yes or no?
Understood, sir.
Okay, sir. The next law is known as
Avogadro's law.
Avogadro. No, the next law in physics is known as the Gay-Lussac's law. What is this Gay-Lussac's law? Huh? Don't know it? Arey, say.
Volume directly proportional to number of moles.
Wow, beta. No. This is this gentleman, Gay-Lussac's law. According to it, for a given mass of an ideal gas at constant volume pressure, this is also known as constant volume law. Pressure is directly proportional to temperature, my dear friends, when the volume is constant. These are the three graphs that you must remember about this. Do it fast, do it fast. We are behind the schedule. We are behind the schedule. And time is a luxury that none of us have. Time is a luxury that none of us have. So do it fast. Fast. Do it fast. Fast, 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 fast. Faster, 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 faster.
Sir.
Done,
Done?
sir.
Well done, sir. Then fatafat do this question. These questions are coming these days. They just test your speed and whether you have understood the concept or not. A sample of O2 is a pressure of 1 atmosphere when the volume is 100 ml and the temperature is 27 degrees Celsius. What will be the temperature of the gas? If the pressure becomes 2 atmosphere, volume remaining 100 ml. So this is constant volume. Volume remaining constant. Gay-Lussac's law. And I wait your answers patiently. With patience. Do it fast.
Sir, 600 ml.
600 ml comes the answer, and this answer is absolutely what? Right or wrong? Absolutely
600
correct.
Kelvin.
And I know that if I take a pause, something will give up. Someone will say something about it, right? Yes, it is
600 Kelvin.
600 Kelvin is correct. There is no doubt about this. Okay. We understand this, or shall I need to do it? P1 by T1 is equal to P2 by T2. Can you do it? Yes or no? T1 is 27 degrees Celsius. Pressure becomes twice, so volume has to become twice. Yes or no?
Yes, sir.
No questions asked, no answers given. What is the next one in line? Law number 4. Avogadro's law. What does the Avogadro law state? Tell me what. Avogadro's law, fatafat.
Volume is directly proportional to number of moles, sir.
Who has given this Avogadro's law? Okay, you can write it this way, but the way Avogadro law goes is like this: equal volume of all gases under similar condition of P and T, pressure and temperature, contain equal number of molecules or moles, whatever you call it. Yeah. If I say very roughly, volume of the gas is directly proportional to, you can say it this way. Volume of a gas is directly proportional to the number of moles when P and T are constant. Do we understand this, or this has gone above our head saying bye bye, I'm going, don't worry about me?
Understood, sir.
Then we have Avogadro's number. I hope everyone knows what is Avogadro's number, so I must not. Then what is the next law? Tell me fast so that I can move ahead in life. Law number 5. Remember, I'm covering your chemistry as well. I'm a very impartial person, so I cover everything. If I cover,
Dalton's law, sir.
no, Graham's law of diffusion. What is this Graham's law of diffusion? This may not come in physics, but it may come in chemistry. Graham's law of diffusion. Anyone has heard this?
Volume is inversely proportional to square root of V, sir.
Rate of diffusion. So when two gases of same pressure and temperature are allowed to diffuse the rate of diffusion is inversely proportional to square root of the density of the gas rho. That is your Graham's law of diffusion. I hope you will remember it now. Whether it comes in physics or it comes in maths, no, it will not come in maths actually. So rate of diffusion is inversely proportional to root of density, or you can say R1 by R2 is equal to under root of rho 2 by rho 1. It will come in chemistry, not so much in physics. But since we are covering it, it's better that we cover everything rather than discover it in the examination hall. What is the next one, my dear friends? Dalton's law of partial pressure. Dalton's law of partial pressure. I hope everyone knows this. We have done question on Dalton's laws of partial pressure. Yes or no? No, yes. What does it state? Hey? What does it state? Total pressure exerted by a mixture of what? By a mixture of non-reacting gases occupying a vessel is equal to sum of individual pressures. If gas alone occupies the entire volume. We have done question on this, yes or no? So total pressure PT will be summation of PI. You just find out the pressure of first gas, second gas, you add them all and you end up with your result. Do we understand this, yes or no?
Yes, sir.
Okay, we have done question on this already. I have just told you because this may come in physics, this may come in maths, this may come in chemistry. Why it will come in maths? This may come in physics or this may come in chemistry. Okay, that is why I'm completing this from all the angles that are possible. That takes us to the theory itself. So we will write the next heading, kinetic theory of gases. KTG, kinetic theory of gases. That is the next heading, kinetic theory of gases. Who gave this kinetic theory of gases? Anyone, any idea? Well, you don't know it, but for a NEET student, they must know it. This was given by Clausius and Maxwell. Maxwell's law of distribution and something like this. You must have heard about Maxwell law of distribution. So you can just remember Clausius. Clausius statement comes in the second law of thermodynamics. Same Clausius. Clausius and Maxwell gave this theory, and which tries to explain what happens. Why does gas exert pressure, or why all these laws are valid, or how can you prove all these laws that we have already seen? Now remember, whenever there is a theory, theory is based on certain assumptions or postulates. Do we understand this? Wherever we have any theory, that theory is based on certain postulates or assumptions. Now, there are a lot of assumptions in this kinetic theory of gases, and you will have to note down these assumptions in as short as possible. So remember them in as short as possible. One of these can come as your question in your exam. What are the postulates? They will not ask you what are the postulates, but they can ask you a question based on these postulates. So what are the postulates of kinetic theory of gases? And I'll tell you each and every one, note them down in short. Every gas consists of extremely small particles. We know this. They are called molecules. Point number one, every gas consists of molecules, very small particles. The molecules of a given gas are all identical. So molecules of oxygen will be same as molecules of oxygen. Molecules of oxygen are all same, but they are different for different gases. Molecules of oxygen will be different from molecules of hydrogen or carbon. First postulate or two postulate. First is every gas is made up of molecules. The second postulate is they are all identical. The molecules of a gas are identical, spherical, rigid, and perfectly elastic. Very important postulate. They are considered to be perfectly spherical, perfectly rigid, perfectly identical, and perfectly elastic. Their size is negligible. Considering their intermolecular distance. Therefore, the volume of the gas, the actual volume that the gas molecules occupy, is very small compared to the volume occupied by the gas. So you can write that as the next postulate. This implies that volume occupied by gas is very, very large compared to the actual volume of molecules. Molecules are very small, but the distance between them is very large. Are we understanding this? Yes or no? So this is going above our head saying bye-bye. I'm going, don't worry about me. Huh? Are we noting it down?
Sir.
Yes, sir.
Yeah. Jaldi note it down. Noted everyone? 3 points, 4 points? Okay, let me discuss the next three, then I'll give you more time. Now, when these, it consists of a large number of molecules, consisting of there are large number of molecules, they are moving randomly in all possible directions with all possible velocities. So they are moving randomly in all possible directions with all possible velocities. The speed of these gas molecules can vary between 0 and infinity. You cannot say what will be the speed of these molecules because it varies from 0 to infinity. Do we understand this?
Yes, sir.
But there is one speed which is the speed of the maximum number of molecules. Remember, there are millions and billions of molecules probably of gas which is moving. They are moving with all sorts of random speeds in all sorts of random direction. But there is one speed which is the speed of maximum particles. That speed is known as most probable speed. Do we understand this?
Yes, sir.
Note it down. One more thing I can note it down here, so I will just include it here also. Now, when these gas molecules are moving randomly in all possible directions, they are colliding among themselves as well as they are colliding with the vessels, the wall. They are colliding with the vessel wall. If they are colliding with the vessel wall, because of this collision, this gas exerts pressure on the cylinder. Now, these collisions are perfectly elastic. This is a very important conclusion or very important postulate of the kinetic theory of gases, that all collisions are perfectly elastic. Are we noting this down?
Noting, sir.
The next postulate is there is no attractive or repulsive force between gas molecules. I told you that the potential energy of these gas molecules is zero. That means they don't interact with each other. Gravitational attraction is negligible because the mass is very small. No attractive or repulsive force acts between the gas molecules. That means there is no interaction between the gas molecules. No interaction between them. No interaction between the gas molecules. Except during collision. When they are colliding, then only they are interacting with each other. If they are not colliding, then if they are colliding, then only they are interacting. If they are not colliding, then they are not interacting. Do we understand this? Have you noted this down? The time of collision is very small compared to when they are colliding. The time of collision is very small compared to the time interval of collision. Have we come up till this point? Particles obey NLM, Newton laws of motion. Their average momentum is zero. Their average velocity or mean velocity is zero because they are moving randomly in all possible directions. But their average velocity ka square is not equal to zero, and that is what you will find it out. That is what we will find out. Velocity ka mean. Two more important points here. Velocity cube ka mean will be equal to velocity raised to the power 5 ka mean, and that is 0. I have seen questions asked on this in your NEET as well as your JEE. Are we noting it down? Yes or no? The next point is between two collisions, the distance traveled by this particle is known as the average or mean free path. It's known as the mean free path. So whenever you come across this term mean free path, it is the distance between two consecutive collisions. Gas molecules are constantly colliding with the walls of container, due to which their momentum changes. Because of this change in momentum, force is exerted by the gas particles on the walls, and this creates pressure. That is how this pressure comes for the gas. How does pressure exert? How does gas exert pressure on the walls of the container? Is because of the collision of the molecules of the gas with the walls of the container. The density of the gas will remain constant at all points. You may encounter questions in JEE Advanced where the density varies, otherwise the density will remain constant. Now, since we have taken that the density is constant, and this will be used, this assumption will be used in kinetic theory of gases. Therefore, the mean square velocity along x, mean square velocity along y, mean square velocity along z are all equal. Pressure exerted by gas in all the three directions are equal. Therefore, pressure is taken as a scalar quantity and it is not taken as a vector quantity, because pressure at any point remains same in any direction. These are very, very important assumptions that forms the basis of our understanding of how gas behaves. The last but not the least, all these assumptions are valid and justified if the gas molecules, the number of gas molecules are taken to be very large. I'll give you 2 minutes to note everything down. Once we are done, we are done. Have you noted it down, bacha?
No, sir.
Don't have to note down everything, beta. Remember, it's a topic from 11th standard. Just have to note down the important points, nothing else. You don't have to note down everything. If a question comes based on this, you should be able to answer it. For example, if they ask you the value of Vx, Vy, or Vz, the root mean square, I'll tell you the formula also. You must understand that all three of them are equal. The pressure exerted by gas is equal in all the three dimensions or all the directions. These are the important things that you must remember. What is the mean free path? They might ask you the definition of mean free path in an objective. Don't have to remember the exact thing. You don't have to write the exact words that are written there. Just write in as short as possible. That helps you in understanding them. Let me know once you are done.
Done, sir.
Boys, are we done?
Done, sir.
Everyone, sir?
Yes, sir.
Okay. Now, whatever formulae I am giving to you, please note them down very carefully. One of these formulae, one of this formula would be coming as question in your exam. It may come in your chemistry paper, it may come in your physics paper. If it does not come in physics, it will come in chemistry. If it does not come in chemistry, it will come in physics. It's just like that. Okay, so let us write the list of formulae that, see, I had to do the derivation. If this was a regular class, I would probably would have done the derivation of this, but I don't have the time that I can do the derivation, and I don't think that derivation is going to make much of a difference now. So I will straight away go ahead and tell you the various formulas that are going to come. The first one is pressure exerted by one molecule, or pressure exerted by one molecule of a gas. Pressure exerted by one molecule of the gas. And how can I write that pressure, anyone? I can write this in this way: 1 by 3 mv square. Where what does m means? M means the mass of the gas. M means the mass of the gas, and v is the speed of that gas molecules. Why it is divided by 3? Well, it is moving randomly in all the 3 direction, and that is why you can imagine that this 1 by 3 curve factor comes into the picture. Okay. Now, the second thing is the pressure exerted by the gas. I will call it as P. Pressure exerted by the entire gas. And what is the formula for pressure exerted by the entire gas? You can write this like this: 1 by 3 m by v into v RMS squared. Do you understand the meaning of this v RMS? Do you understand the meaning of v RMS?
Root means square velocity.
RMS, VRMS, RMS. What do you mean by VRMS? RMS means root mean square velocity. Root mean square velocity, and I call it this way: root of mean of square of velocities. So how do I find this root of mean of square of velocity? I take the velocity of one gas particle. I take the velocity of one gas particle, then I square it. I take the velocity of one gas particle and then I square it. Then I find the mean of it. Mean means average. And then I find the root of it. Whatever I get after this is known as VRMS. Root of, mean of, square of velocity. You take velocity, make it square, find out the mean or average, and then take the square root. If I just write it in more elaborate fashion, it will be like this: v1 square plus v2 square up till vn square divided by n. It is the root of this value. Do we understand this, my dear friends?
Understood, sir.
Everyone understands this? So this is what I mean by root mean square velocity. Remember, each and every formula that we are doing right now is a potential question in itself. Potential question in itself. Potential question in itself. And I repeat it. Now, We can have different ways in which we can write the RMS velocity of the gas particles. There are different ways in which I can write equation number 2. For example, I can write equation number 2 like this: 1/3 into rho into VRMS square. Do we understand this, how I've written this? Yes or no?
Yes, sir.
Okay. Fourth number. Now, in fourth number, I can write it. These are the two forms that you should remember. Now we can write the various form of VRMS. How I can write VRMS, and then you can understand that I can write VRMS in different ways. I can write it as 3 times PV by the total mass of the gas. Now PV is nRT. Total mass of the gas is N into molecular mass. So now I have the formula 3RT by M naught, where M naught is the molecular the molecular mass of the gas. Do we understand this? You can also write it as under root of 3P by rho. Do we understand this?
Yes, sir.
Anyone understands this? Yes or no?
Yes, sir.
You can also write it 3 times KT by small m. Remember, and as I always tell you, whenever you have R, you will have number of mole or molecular mass of 1 mole. Wherever you have K, you will have molecules or number of molecules or mass of the molecule. Do we understand this?
Yes, sir.
Are we getting what I'm saying here, bacha? Okay.
Done, sir.
Everyone is noting them down. These are most important formulae in your entire thermodynamics. Note it down, everyone. You will not, you will find this formula, but I'm giving you everything sequence wise that will help you in remembering and understanding them. Have you noted this down?
Yes, sir.
This is the next formula. If someone asks you the square average value along x-axis, this will be 1/3 of VRMS. If they ask you value, RMS value along y-axis, it will be VRMS divided by √3. Do we understand this? Huh?
Yes, sir.
You will not find these things, beta. I've collected them from, put them in one place so that I can tell you everything in a systematic manner. Average number of molecules for each wall. If the total number of molecules are n, there are 6 walls in a cubical cylinder, cubical space, n/6. Number of molecules along each axis will be n/3. I hope I am making sense and I'm not talking nonsense. Have you noted it down, bacha? Huh?
Done, sir.
Okay, let me bring that. Okay. Now, if I talk about, and these are some confusing terms, sometimes you might hear a term total translational translational kinetic energy of gas. Total translational kinetic energy of gas. How do you find out the total translational kinetic energy of gas? So remember these formulas, they will come in one form or the other. So it will be equal to 1 by 3 into the total mass of the gas into VRMS squared. You can put the value of VRMS and you can write it as 3 by 2 PV, or you can write it as 3 by 2 nRT. This is a very, 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 very important point. Total translational kinetic energy of gas molecules. Total energy. Total translational kinetic energy. Have we noted this down, bacha?
Yes, sir.
Okay, the next term that is going to come will be asked in different ways. They can ask you like this: translational kinetic energy per mole, or for 1 mole of molecules. What is the translational kinetic energy per mole, or 1 mole of molecules? Can you tell me how much will be this per mole?
3 RT by 2.
Yes. So remember this value. So I call it kinetic energy per mole. TKE, transitional kinetic energy per mole, is 3 by 2 RT. Are we understanding this?
Yes, sir.
Next one. Sometimes instead of calling it transitional kinetic energy per molecule per mole, they can also call it average transitional kinetic energy per mole. It means the same thing. Do we understand this? Because this is not the value of all the molecules. It is averaging of everything. Do we understand this? When we talk about gas molecules, we cannot say this will be the value. It is the average of all. Do we understand this?
Yes, sir.
The next thing that they can ask is average translational kinetic energy per molecule. Translational kinetic energy per molecule.
3 by 2 KT.
So remember, whenever we talk about per mole, it is R, per molecule, it is K. 3 by 2 KT. I can also devise a term, and I've seen one question once in one of the exams. I don't remember that exams. They've asked average transitional kinetic energy per volume. Don't get confused. It is similar. T KE per volume. You can write it as 3 by 2 P. Do we understand this? Huh? We're just gone above it saying bye bye. I'm going. Don't worry about me. I'm gone. Bye bye. Bye bye. Bye bye.
No, sir.
Pakka na sir? No kacha pakka, pakka pakka, or no kacha, no pakka, sir. Everything going above our head, sir. What kacha, what pakka? Huh?
Done, sir.
What have I done, sir? Okay. There are also two more speed that we must think about. The first one is known as average speed. This is simply the average of all the speeds. Remember, average velocity is 0 because velocity is a vector, it gets cancelled. Do we understand? Huh? But average speed is not 0. Do we understand this? They might ask you a question, what is the average velocity of all the gas molecules? And they will give you the formula of this. And you will take dung and you will get 0, not 0, -5. Average velocity of gas molecules is 0, not average speed. So average speed becomes 8 by pi RT by M naught. Do we understand this? This ka root. Huh?
Yes, sir.
Or you can write it as 8 by pi. Right? 8 by pi KT by small m. Or you can write 8 by pi PV by total mass m. Or you can write 8 by pi P by rho. Do we understand this? Or this I gone above what I'm saying bye bye? I'm going, don't worry about me. V most probable. Now remember, this value actually comes as 1.59. Remember this because it will help you in understanding what is the relation between the two. This will be coming as 1.9, 1.59. We talk about most probable speed. This is the speed of the majority of the molecules. V most probable. I will just write one formula and then you can write the other formula on your own. 2 times KT by M. You can write the next of the formulas, yes or no? Remember this relation V RMS is greater than V average is greater than V most probable. These are the relation between the three. I hope you understand this. I'll give you 2 minutes to note this down.
Done, sir.
Done, sir? Okay. Now, important points. Number 1, VRMS is directly proportional to the root of absolute temperature. Do we understand this? Yes or no? No, yes.
Yes, sir.
VRMS is directly proportional to the root of absolute temperature. VRMS is inversely proportional to the root of molecular mass. Yes or no?
Yes, sir.
Why is that so? RT by M naught. Yes or no?
Yes, sir.
What about pressure and density? What about pressure and density? Remember, VRMS does not depend on pressure P or density rho as long as T is constant. Do we understand this, everyone? Anyone is there?
Understood, sir.
P by rho. The value of P by rho. P by rho is RT and RT. Now, you can change pressure in such a way that density also changes, but the ratio of, or it's not ratio, but the value of P by rho remains constant. The value of P by rho can only change when the temperature of the body changes, when the temperature of the surrounding changes. Do we understand this? That is why we say RMS speed is directly proportional to the root of absolute temperature. You change the temperature, then only it changes. It is inversely proportional to the root of molecular mass of the gas. Remember, this molecular mass of the gas should be in kgs. Absolute, SI unit. Do we understand this?
Sir.
Okay. Shall I give you a question now?
Yes, sir.
Okay, this one. This is the question. I'll give you 2 minutes to solve this. This is a question that has come in previous year JEE, NEET, as well as in your engineering exams. The cylinder of capacity 20 liters is filled with H2 gas. The average, the total average, whenever you say total, that means the total of everything. The total average kinetic energy of translatory motion of these molecules is it now. What is the pressure? I'll give you 2 minutes to solve this. Yes, we got the answer, bacha. Hello?
Option D, sir.
Option D, 5 into 10 raised to the power 6 Newton per meter square. That is correct. How did you get it? Did you get it, or you are looking from the answers and telling me?
Total
Yes.
total energy equals to 3 by 2 into PV.
Very good. Total transitional kinetic energy is 3 by 2 into PV. If I would have said per mole or per molecule, then it would be divided by N, capital N or small n. Well done. You must remember these things. Can we move on to the next question, beta?
Yes, sir.
Okay. This one, a very famous question. It actually came in one of the IITs first. Then it has been coming regularly in your JEE and NEET. N molecules each of mass m of n molecules. Small m is the mass of one molecule of gas A, and 2n molecules each of mass of 2m of gas B are contained in the same vessel at temperature T. Remember, temperature is same. The mean square of velocity. When I say mean square, it is RMS ka square. The mean square of the velocity of the gas molecules is V, and the mean square of x component of x component. Remember, x component of molecules of A is W square. What is the ratio of W square by V square? Remember, I gave you important notes. I hope you can manage it now. 2 minutes you will have. No, you will not get you. This but any answers do we have? Shall I do it? Shall I do it, bacha?
1 minute, sir.
Okay. Okay, I think I've given you enough time. Probably you are stuck somewhere. Let me help you out. How are you going to do this? Yes. So, if I write the value of VRMS square for anything is 3 KT by M. Yes or no? Huh?
Sir,
Okay. VRMS for mass of the molecule is 2m. VRMS for B is V, right? So let me write it as, I can write it as V square will be equal to 3 times. Remember the temperature is same for both. Temperature is 3. So 3 K into T by 2m is your V square, which is the RMS velocity for gas B. Do we understand this?
yes, sir.
Now, how do I find the RMS velocity for gas A? The mass of the gas is m, and the x mean square x component is w, and w square. So I told you the relation, right? So the VRMS velocity of gas B becomes 3w square. Yes or no?
Yes, sir.
That's it. So 3 times W square, that is the VRMS of gas A, that will be equal to 3 kT by molecular, no, the mass of one molecule is M. Now we can very easily, bacha, find out the ratio of W square by V square. The ratio of W square by V square will come as what? Two by three. Do we understand this, bacha?
Yes, sir.
That is the answer, sir, for this question, sir. I hope we have understood this, sir. Yes or no, sir?
Yes, sir.
Anyone got the answer here?
Yes, sir.
Why did not you say it, bacha, then? Anyways, shall we move on to, we have to solve 2 or 3 more questions and then we are done with this chapter once and for all. I have sent you the sheet. Did you get the sheet for this?
No, sir.
I'll send it again and I'll send it right now. I'll mail it up. You solve this question and I'll mail it up again. Gases A and B, something is given. Find the ratio of RMS speed. What is happening? Where is it? Yes, bacha. Anyone with any things that looks like an answer? Huh? No. Shall I help you out? This is temperature. This is temperature of A and this is temperature of B.
Option D.
Option D, 0.5. It's absolutely wrong. It is the ulta of that. Option A. Huh? So, shall I do it? Remember, don't do mistakes in the ratio. VRMS of A divided by VRMS. Oops, what is this? Yeah. VRMS of A divided by VRMS of B will be root over TA by MA into MB by TB. Yes or no?
Yes, sir.
That's it, your answer, my dear friends. TA by MA divided by TB by MB is root over 4. Yes or no, my dear friends? So
Yes,
the answer
sir.
is 2. How did you get 0.5? Yeah, this is minus 5 marks straight away. In the easiest question in the entire universe, you get minus 5. Do we understand this?
Yes, sir.
Don't make stupid mistake like this. This is minus 5 straight away. Next question. Look at the question, solve the question, get me the answer as soon as possible. The more the number of questions that you do, the better you are going to be. Yes, bacha. Any answers for this one? I'm waiting. Huh? No answers.
Sir, wait for 1 minute.
I will wait for 1 minute.
Sir, option C.
Option C. How did we get option C? The RMS speed of gas molecules is 300. You have read the question carefully, no, bacha? No, there is a mistake in the question. You read it carefully, right? You're getting option C. Sure. Can you try again? Done a mistake probably. A very, very basic mistake. Okay, I will do it for you. The root mean square of hydrogen molecule. Now let us say we write the formula of root mean square 3RT by M naught. Now VRMS of hydrogen, let us call me H, divided by VRMS of oxygen will be equal to 3R gets cancelled, temperature of hydrogen divided by molecular mass of hydrogen multiplied by molecular mass of oxygen divided by temperature of oxygen. ठीक है बच्चा? Just be careful. Temperature is 300 divided by 2. Molecular mass of oxygen is 32, my dear friends, divided by 900. So it will be taking root 16, 4 by root 3. Yes or no, my dear friends?
Sir,
So speed of oxygen will be speed of hydrogen into root 3 by 4, my dear friends. So the answer is 1930 into root 3 divided by 4. That is the answer, my dear friends. Do we understand this? Yes or no? No, yes?
yes, sir.
That is the answer. And the option which is correct, I think, is option B. Yes or no?
Sir,
Have we understood how it is done?
yes, sir.
Have you understood the concept of RMS speed of a gas and what type of questions can come? The questions that can come in RMS speed of gas are like this. They will give you the RMS speed of one gas at one temperature and they will ask you some other gas at some other temperature. I think you can handle these questions now. Yes or no?
Yes, sir.
Okay, the other type of questions are based on that pressure and volume. They will ask you they will give you pressure, volume, or temperature, and they will ask you what is the average kinetic energy per molecule or average kinetic energy per mole. You can do this? Yes or no?
Yes, sir.
Those are the two types of questions that are expected. There is also one more type of question that is expected, and I will give you as a homework so that you can try it and tell me the answer in the next class. Remember, this is more a question on Newton's laws rather than a question on thermodynamics, and this is more likely to come. This is more likely to come in a JEE Advanced rather than a JEE Main or a NEET. A mass of hydrogen molecule is given. 10 raised to the power 23 molecules are colliding per second on a stationary wall of area 2 centimeters square at an angle of 45 degrees to the normal and reflected elastically with a speed of 10 raised to the power 3 meter per second. Find the pressure exerted on the wall. So I'll give you this question as homework. Try it and tell me the answer in the next class. When I say next class, that will be the class on Sunday. So take care. God bless you all. Bye-bye. We'll discuss this question in the next class. Don't worry. Before moving on to the next topic, we will discuss this question. Okay? Take care.
Sir.
God bless you. Have you noted this done?